Hello everyone. Welcome to the lesson on how to create a box and whisker plot, a flipped lesson. And you can see on the left is a box, on the right is a cat with whiskers. Now these two things have nothing to do with creating a box and whisker plot, but they're good to think about. A box and whisker plot is actually a way to show a picture of statistics, and I'm going to show you how to create one. Before we do that, you have to understand the concept of a quartile. So what is a quartile? A quartile is one of 3 points in a data set that divides the data into 4 equal groups, with each group consisting of 1/4 of the data. So that's why it's called a quartile, because each quartile represents 1/4 of the data. 1/4. So if we have a data set, let's forget the interquartile range for a second. Let's say we have a data set that's broken into 4 equal parts. Every 25% represents a quartile, and the numbers that represent those quartiles are the spots where the data is split into 4 equal parts. So every data set has 3 quartiles: quartile 1, quartile 2, and quartile 3. One thing you're going to want to keep in mind is that quartile 2 is the same thing as the median. You might remember from previous experiences that the median is the middle point in a data set. In addition to knowing the quartiles, it's also important to know something called the interquartile range. You might know from the past that the range is the highest value minus the lowest value. So the interquartile range of a data set is the difference between the top 25% and the bottom 25%. So you would take quartile 3 and subtract it from quartile 1. But all these words are new to you, so let me make this a little bit simpler for you. I want you to think of a basketball game, and to do that we're going to look at Carmelo Anthony. So here's Carmelo at the beginning of a game. He's pretty happy. The game just started. But if anyone's a Knicks fan, you know that these things don't go well. So the game starts, and that is where we are here. So when you think of a data set, think of the bottom value as when the game starts. Then as the game progresses, you're at the end of the first quarter. You can see things aren't going so well for him there. Well, I want you to think of the end of the first quarter as where the first quartile is. At the end of the first quarter, 1/4 of the game is done. In a data set, at the first quartile, that's where 1/4 of the data is. Then we have quartile 2, and think of that as halftime, just like the median. Halftime is the same thing as where the second quartile is. It's the spot where the data is split into 2 equal halves. Then you have the end of the third quarter. You can see he's looking a little bit upset by now. That's probably because they're losing by about 40 at this point, but that's not the point here. Think of the end of the third quarter as the third quartile. By the end of the third quarter, 75% of the game is done. And then you have the end of the game. And you can see he looks defeated because the Knicks probably lost. Think of the end of the game as your maximum value. So that's what quartiles are. You have 3 quartiles. You also have your minimum, which is your lowest value, and your maximum, which is your highest value. When you put all 5 of those things together, it's called the 5 statistical summary. And you need the 5 statistical summary in order to create a box and whisker plot. So what does all of that mean? Well, let's take a look at what a box and whisker plot looks like. A box and whisker plot, which is sometimes called a box plot for short, is an image of a data set's quartiles and the 5 statistical summary. So I want you to look at the one on the left, and I'm going to outline a couple things for you. Those blue dots represent the 5 statistical summary. So think of the 5 numbers I just talked about on the previous page. the first dot all the way on the left is your minimum value. That's the lowest possible value in that data set. The second blue dot represents where the first quartile is. So that represents the spot where 25% of the data is passed. The third dot represents your second quartile. That's the midpoint of the data. That means that on the left side is 50%, and on the right side is 50% of the data. The third dot is quartile 3, which is where 75% of the data lies below. And finally, that last dot is your maximum value. Okay, now let's look at the one on the right. See if you can identify where those parts are. The left number here, which is 130, is your minimum. The next indicator, the left part of the box they call it, that's your first quartile, which looks like is approximately 145. The middle of the box is your second quartile. And the right of your box is the third quartile. And then at the end, that's your maximum value. So why do they call this a box and whisker plot? Well, it's very simple. The box portion, that's your box. And if you're good at guessing, these parts here, that part and this part, those are your whiskers. The box shows you the range from quartile 1 to quartile 3. And the whiskers show you the extreme values, the minimum and the maximum. So how do we create that? It's very simple. Let's go through the process together. Assume that I have a small group of 9 students in front of me, and I want to know how the scores on their previous tests were distributed. Here's what I do. First, I'm given the list of the scores. So here are my scores. 98, 55, 84, 90, 78, 82, 100, 94, and 96. 9 values. Your first step is going to be to organize the data from least to greatest. So let's do that. Pause the video if you'd like to try these things. But I'm going to do the ordering. I have 55, 78, and actually before I go on, something that helps you is to cross out the data as you write it so that you know you've taken care of it. Then I have 82, 84, then I have 90 and 94. I have 96. I have 98. And I just covered the last one. It's 100. 9 values. Make sure that the numbers that you wrote out are the same amounts as the one that you had in the original set. So now, I need to find what's called the 5 statistical summary. That means that I need to find my minimum, my maximum, I need to find my median, which is the same as the second quartile, and I need to find my first quartile and my third quartile. Well, the minimum and the maximum are the easiest to see. The minimum is 55. The maximum is 100. This is where it gets a little bit tricky. Now you need to find the median. So you need to locate the center. What is the middle value? Well, when you have an odd number of values, there's always one in the middle. In this case, the number in the middle is 90. Okay? You can tell because there is an even amount of data values on the left side of 90 as there are on the right side of 90. So that's my median, or my second quartile. So here's where it gets tricky. Now you need to find the first quartile and the third quartile. All you need to do is basically find the median of each half. The lower half, which is from 55 to 84, you don't include the median. that will be, the middle there will be your first quartile. So in the middle of those 4 values, right here, are your 4 values. The middle is right here, between 78 and 82. So you average those 2 out, and you get 80. So my quartile 1 is 80. So on the right side, my 4 values there are from 94 to 100. The middle is right here between 96 and 98, which is 97. So my third quartile is 97. Okay? And lastly, now that you have the hard part done, you just need to create the plot. You need to plot the points of the stats on a number line for step 3. So you create a number line. Don't draw lines like me. Mine looks like a snake. But anyway, you'll get the point. So there's your line. I need to make sure that it goes from 55 to 100 at least. So I'm going to start down here at 50, and I'm going to let every box equal 5. So that'll be 55, this will be 60, 65, 70, 75, 80, 85, 90, 95, and I'm going to extend my line just a bit. You're allowed to do that. And over here will be 100. So above the line, you're going to plot those points. The minimum is 55. The maximum is 100. The median is 90. The first quartile is 80. And the third quartile is 97. I'll approximate that right about here. And then step 4 is where you get to create the picture. You're going to place a box around the interquartile range, so that's from Q1 to Q3. So let's draw that box. Okay? Then you cut the box at the median. So you draw a line through that. And then you draw whiskers to the minimum and the maximum values. And there you have your box and whisker plot. I want you to note something though. This term outliers, those are indicated by long whiskers. So look at the 2 whiskers. See if you can figure out which one might be an outlier. An outlier is something that's really far away from the pack. So 100 is not really that far away from the rest of the values, but 55 is. Most of the scores were at least around 80 and above, and 55 is really far away. So this could be considered an outlier, this 55. And let's talk about a couple more things so that you understand what the plot represents. Remember that the interquartile range is between Q1 and Q3. And make sure you understand that every part of the box and whisker plot represents 25% of the data. So I want you to remember that, and I want you to think about something before we go over the lesson tomorrow. Think about what it means when a part of the box and whisker plot is really big versus when a part of the box and whisker plot is really small. So I hope after watching this video you have a better understanding on, first of all, what a box and whisker plot is, and also how to make one. You may pause the video, rewind it as many times as you need to, and take as many notes as you need. Thank you for watching.